In this part of the lecture, we'll learn about your first design pattern, namely the iterator pattern. And let's see what the learning objectives are. So we hope that you will be able to understand, number one, the motivating problem for the iterator design pattern. So just remember that for every design pattern, the motivating problem is different. So not necessarily there will be a silver bullet that can solve every problem. So you have to see under what circumstance should you apply a particular design pattern. And number two, we want to see from the supplier's point of view, how can you actually implement the iterator design pattern. So this is something new. And number three, as a client, how can you use the iterator design pattern? This is something you have seen already. Remember in the Lab 0 introductory tutorial videos, we learned about how you can use the across syntax. Specifically, you can across a linked list, or you can across an array. So it is simply because the array and linked list classes have implemented the iterator design pattern. That's why we can use the across. So that's something I will show you briefly. And finally, there will be a challenging exercise about using complicated architecture. Specifically, I want to draw example from the iterator design patterns and also how you can use generics. So this will be like a strengthening exercise from last week about how you can use generic classes. And the challenging exercise, I'll give you the exercise problem there, and then I'll let you think about it, and then I'll discuss the solution, not in the lecture part, but I'll discuss that in the Q&A. It's up to you if you want to know the solution, but it will be covered in the quiz. So please make sure at least you follow through the Q&A recording. Okay, let's start with what are design patterns. So throughout the course, we're going to discuss maybe about 5 or 6 design patterns, but you have to know under what circumstance you should use which one. So solutions to recurring problems, basically, especially when you're programming in object-oriented programming, that's your context. In that case, for a particular problem domain, you have to solve using a different pattern. And some problems are simply occurring again and again, so you can use a particular solution for that. So every design pattern that we talk about is basically more like a lesson learned from the previous developer. They have heuristics, what they have for restructuring your code, and also it can be systematically maintained and extended. So that's something I'll discuss for every design pattern. Every time, if you want to extend your architecture, how would you do it? And every time you want to maintain, how would you do it? So that's something you want to focus on for every design pattern. Okay, and also some very important warning to give to you, as I just illustrated, not really illustrated, as I just mentioned. So a pattern is only suitable for a particular problem. So which means iterator pattern may not be able to be used in a problem context where maybe an observer pattern should be used, right? So you want to say, you want to judge to see the problem you're given, which pattern should be applicable. That's something you have to judge as a designer. Okay, so always understand the problem before the solutions. So that's really important. For every design pattern, I will always give to you the motivating problem to think about first. Okay, so let's think about what the motivation is for the iterator design pattern. Let's now consider 2 classes. Let's say we have a class called cart, and also we have simply an array of order. You can see the feature here, this export status over here simply does nothing, which means it's exported to any class. So it's as if we said public orders over here. And then we have a class called order. So we got 2 classes here. And then the order, for simplicity, only got price and quantity over here. Let's say they are simply just attributes, and they're also public. And then we got another class for the clients over here. Let's say we got shop, and shop is simply going to be a clients of the cart. So the cart over here is a supplier, right? You can see we can draw some client-supplier relation between these 2 classes. Let's say for this particular query, we are trying to calculate the added sum of all the price and quantity in a particular cart. Let's say we use a from until loop, and we know very well in order to go over an array, we simply say start from the array that lower index until we are strictly larger than the upper index, right? And then we want to say every time we're simply going to aggregate that particular order at index I, and then multiply the price by the quantity and then add it up. So eventually the result is going to be something we can return, right, implicitly. And then to make sure, you also always say I is assigned to I plus 1 to really avoid infinite loop. Okay, so that's about the easy design here between the client and supplier. So now I want you to think about problem. And typically, when I ask you about whether there's going to be any design problem, I'm not really asking you to check whether the code will actually work or not. This piece of code will actually work. So correctness is not an issue over here. So when we talk about design, you want to think about what does it really mean when I try to change this particular design. For example, if I want to change my implementation strategy, let's say from array into another data structure, let's say linked list. If I really make that change, can you imagine if the consequence is something that will be pleasant or unpleasant? If it is unpleasant, of course, that will not be a good design for us, right? So whenever I ask you about if there's any design problem here, I'm not really saying if there might be compilation or if there might be like a failing test cases. Not really. I'm really asking about when we later want to extend or maintain this particular design, is it really the best we can get, or we can improve it? Okay, so you can pause the video and think about it before I tell you what the answer should be. Okay, assuming that you have thought about it, so let's say this. The problem really is this particular design violates information hiding principle. Remember what information hiding principle is. Everything that's actually likely to change. For example, here we are using an array of order, and it's actually quite likely to change because supplier may not use array all the time. They might decide to maybe change from array into a linked list, and then from linked list to another tree or to another hash table. So it's really something that's likely to change. That's something that's unstable. What it should have done is the supplier should have hidden it. This particular, so they should have said feature should be exported to none for this particular orders. Okay, they didn't do it. So now what's the consequence of not doing this? The consequence is, let's say if we simply change from an array over here into a linked list, okay, that's a supplier size change, and as long as the supplier's change wouldn't affect the existing clients, we might still be happy. However, when I change from array into linked list, am I going to have any compilation problem that's going to upset the clients? The answer is yes, because remember, if I change this to linked list over here, so that means features over here, let's say lower and upper over here, they are not features that are supported by linked list anymore, because lower and upper, these are array specific features. So that means the clients, the existing client who rely on array specific feature, they will be very upset, because now suddenly supplier simply changed their implementation from array into linked list. So the client's code wouldn't compile anymore. So that's why this design is not good. Okay, let me recap. The reason that this design is not good is because it violates the information hiding principle. Because the clients over here, the client shop was exposed the details about supplier's secret over here array, which is likely to change. So that violates the information hiding principle. We will summarize what the information hiding principle is, but we also talked about it last week when we talk about abstraction function. So you can also review that in that context as well. Okay, over here, so if you change from array into linked list, you can see now what you expect the client to do to change. The client shouldn't be too bothered by when the supplier changes their secrets. So now you're forcing the clients to actually change in this way. So they may have to use the cursor operation instead. Okay, so it would be very nice if somehow, number one, you can somehow hide this particular feature section by saying it's exported to none, number one. Number two, you want to say from the client's point of view, rather than trying to go over the orders, the underlying orders using either linked list operation or array operation, we want to have a more generic way or general way to actually just go over the item one by one. So that would be the motivation for the iterator pattern. Okay, it's a very brief illustration here, but now I want to just really strengthen your impression about why the existing design is actually pretty poor. Okay, so you were given this particular source code already. It's called the iterator pattern example starter. Okay, so this is exactly the same setup that I have done. So you got order over here, right? I just added some precondition and postcondition over here. So I also got some exercise for you to do. You can look through the source code and do the exercise. Let's say we got our cart class over here. You can see I simply got orders, array of order, right? You can see there's no exported to none, so it's simply public to begin with. And then the shop, the clients over here, we simply got over here checkout over here, right? The checkout over here, we actually use lower and upper that simply depend on very specifically to array. Okay, so that's a problem. So let me illustrate again what the problem is. let me go back to the supplier, which is a card class over here. Let's say now I decided that I'm going to change my implementation strategy from array into linked list. So what I will do is I'll change this from array into linked list. Okay, so now if it was a good design, so that means all the changes will only have to be done on the supplier side. It shouldn't really affect the client side. So now if I hit compile, what the problem is, number one, let's see. Actually, it's more than what we just said. You can see something about upper, which we set, and something about make empty as well. Oh, okay, actually I forgot. Remember for the linked list, in order for you to create a new linked list, you're gonna say make rather than make empty, right? That's another thing. So now if you go there over here, you can see now we are now in the client's code over here. You can see we are talking about lower here, which doesn't exist, and also for upper, it also doesn't exist for the clients, for the array. So that's the problem. Okay, so now what should we change over here? Let me say the following. Let me just give you a little bit idea, so you can, when I illustrate the solution, it'll be easier for you to follow. What I want to do, number one, is I want to say rather than just being public, I want to export it to none. Number one. Okay, so now no one can actually get access to these orders directly. So the good solution is we want to really make the current card class iterable, so that any public client who want to use this class, rather than being exposed to the underlying data structure, they can use another way, which is much more public and much more stable. That's the intuition. Okay, so I also got to change over here because now orders is a linked list. So I'll just say make rather than make empty. Okay, so now I'll just say make over here. Okay, so now what I get is actually, let me just tell you where we are, and then I will go back to the illustration. What we are having now is, you can see now, in this particular client class, we cannot get access to card.orders again. Okay, if you try to read the error message again, it's actually quite informative. If you expand the error message over here, it's saying the following. In the checkout feature in the shop class, right? This is the context of where we're using it. And then it's saying that you're referring to basically this line here. I is assigned to card.orders.lower, right? You're trying to refer to this particular orders feature. However, this orders feature is not exported to the shop class, the current class. Why? Because if you go back here, we already set in the card class over here, the orders is only exported to none. So that means it's completely private. Okay? Which is good. We really want to hide this particular secret for the supplier. We don't want this to be exposed. So now what we got so far is really something that we want to continue. So we want to say from the client side, they should not really get access to the orders directly. Instead, this is what we would like to do. Okay, what we want to do is we simply want to say it would be very nice. Okay, let me just Control K over here. So it would be very nice if we can have a very general way, and using across would be a very general way. So I can say across over here, okay, just to use loop because I'm not doing the implementation. So I can say rather than just going over card.orders, so this is already private, I cannot do that anymore. So it would be very nice if I can go across card directly. Let me just write it out to show you. And then for the card, underlying has the underlying collection of orders. So I want to get order by order. So I would say I want to go across the cart, and every time when I get something back, let me just use the is over here. I should really get, every time I would simply just get order back. I'll just say ORD, order. Okay, actually get the order here. Every time the object I get back from cart will just be an order. And then what I can do is I can say result is assigned to result plus, and then order, which will be of type order, dot price multiply order dot quantity. Okay, so logically speaking, it's the same. But now the difference is when the client is actually trying to use across cart, they wouldn't necessarily know what's really the underlying data structure that's being used, either an array or a linked list or a tree. They don't have to know. All they know is they're going to get the order one by one at a time. Okay. Now, as soon as I say compile right now, it's not going to compile. Okay. Let's see the first error message, but it's normal because we still need to implement the iterator pattern. So now if I go there, it's saying that you cannot go across the card just yet. because you can only use the across over an objects if it's iterable. So iterable is really the essence for the design, the iterator design pattern. So if you expand the error message over here, it will tell you that, so now the target type should be iterable in order for you to use the cross keyword. However, currently the card, which is of type, the card is of type over here, let me show you, is of type card, and the card over here currently is simply just a normal class without saying that it inherits from iterable. So that's why you cannot use the cross notation on the card objects just yet. That's something we'll do in just a moment. Okay, hopefully so far so good. I just want to illustrate to you what's wrong with the original design and how we can gradually move to an ideal design using the iterator pattern. Before I do that, let me just go over a little bit of slides and then we'll continue. Okay, so this is the iterator pattern design architecture. So let me move on to my iPad to explain to you the critical classes over here and what you should really look at. First of all, let's talk about clients versus supplier. So we got clients over here in one cluster for the iterator pattern. Also, we got a supplier on the other side for this iterator pattern. For the clients, the only thing I want to point out to your attention is you can read other details yourself. Over here, you can see over here, this is the accounts declaration, and that simply is an iterable. And iterable is referring to this particular deferred or abstract class, programming from the interface, but not from the implementation principle we are following here. And then anything that's iterable can be dynamically the type for this particular account. It can be array, it can be linked list, or it can be any collection type or any iterable class you created on your own. And then that's why we got this particular client-supply relation. Okay, this is something we have learned already. Just want to point out to you. And also, this will be also a very good example about how you can create contract view for the various feature for your classes also within variants. Treat that as a good case study for you when you draw a design diagram as a reference point. Okay, about the supplier side, that's really what we want to learn. So there are two critical classes you should really distinguish very well for the iterated design pattern. So the design pattern contains two classes over here. One is called iterable over here. And the other class is called iteration cursor. So these two classes, not surprisingly, are simply just deferred, which means they're just general classes over there that define the interface for whoever want to instantiate the iterated pattern to inherit from them. Okay, and then so for the iterable class, the only query or feature you have to implement will be something called new cursor, and in this case it's deferred, and then it's of type iteration cursor over here. That's why you got a client-supply relation over here that's pointing to iteration cursor. Okay, and for the iteration cursor, either you can simply reuse the library iteration cursor that's already implemented for you, which I'll illustrate to you how to use it, or you can simply create your own iteration cursor class, and in which case you have to implement three features. One is called item. Whenever you want to return something from the iterable one by one, what's each item, right? And then also you will have to say after, if you go one by one, when will be the end for the termination? And also the fourth, you want to make progress to say, now I want to see item number one, next time fourth, I will say item number two, and etc. So these are the two classes in order for you to implement the iterated design pattern. So this pattern here is very common for any programming language, so it's not just unique in iPhone. Okay, so let me just tell you what's the rest of the supplier side. All the library collection classes in the iPhone-based library, so they are iterable by default. These always are iterable. So I just call it iterable collection over here. So for example, we got a hash table, we got a linked list, and we got array. So these are the common data structures you may want to use. So if that's the only data structure you have in your implementation, then you can typically get just new cursor for free. Because array being effective, it should have already implemented the new cursor already. Otherwise, because array also inherits from iterable over here. If array did not implement the new cursor, the array would have been deferred, right? You can see the logic over here. So that means every library class that's effective, they must have already implemented the new cursor feature because every library class is iterable. Okay. Similarly, for linked list, they also got new cursor, and for hash table, they also got new cursor, right? It's just that the dynamic type for the cursor is different. For example, in the case of array, it's array iteration cursor, linked list iteration cursor. and also hash table iteration cursor. They have a common ancestor, which is called indexable iteration cursor. And not surprisingly, finally, you ultimately go to this particular iteration cursor class, which we are obliged to really inherit from for the iterator pattern. It's a very quick walkthrough of all the critical classes. Again, in order for you to instantiate from the pattern, you have to know about iterable, and also iteration cursor. And for the iterable, you should really implement a new cursor feature, which is of type iteration cursor. Okay, that's the critical points. And then this part over here for the diagram simply just shows to you how the library classes actually inherits the iteration cursor. I mean the iterator pattern. Okay, so now let's talk about, for you as a supplier, how can you instantiate the iterator design pattern. I'll return back to the slides, and then let's go over a little bit slides, and I'll show you there are two possible ways you can implement the iterator pattern as a supplier. First of all, let's review information hiding principle. You should really hide your design decisions that are likely to change. In this particular example, you might want to change from array into linked list, or linked list into hash table, and etc. So that design decision should be hidden. It should not be public so that it will affect the clients, as we shown in the original problem there. So you should really have a stable API. That's really the point about having information hiding. Okay, so change of secrets does not affect the client using the existing API. In the original problem there, as soon as you change from array into linked list, the client's code, in the worst case, does not compile. That's a really big problem there. Okay, so now what will be the steps to implement the iterator design pattern? Okay, so there are two scenarios which I'll illustrate one by one. Okay, number one, for both approaches, you should really let your supplier class, for example, the cart class, which we'll do first, you should really let it inherit from iterable of G. So the iterable class from the IFO library, which I just showed to you on the architecture diagram, is a generic class with just a single generic parameter. So when you inherit from that class there, you have to decide what G you want to instantiate that into exactly, right? So I'll talk about it once I get there. So now over here, we have to talk about, so as soon as you inherit from iterable, you will have to implement this particular new cursor feature, right? Remember in the architectural diagram, you have to implement this particular new cursor that's deferred, right? So whatever class you inherit from iterable, you have to implement the new cursor query. So how can we implement that? For example, I might say I have, and that one there is going to return iteration cursor over here, G, right? So now what should we instantiate G into? For example, we might instantiate G into maybe order. That's one case, right? I'll talk about it in just one moment. And then, so let's talk about approach number one, which is so-called easy case. So now if the initial library data structure is already iterable, which means my underlying implementation, let's say an array or a linked list itself is already iterable, I can definitely just call their new cursor for free. Okay, that's an easy case. Let me illustrate to you on the iPad, and then I'll show you on the iPhone Studio as well, just for completeness. So let's see the diagram over here and think about what we're doing here. Again, remember these two are the critical classes for the iterator design pattern over here, right? So our goal really is to implement this particular new cursor class. And now let's say in the example that we talk about, we want to have a class called cart, right? So this is our supplier class that we want to use the across notation. The step number one, we want to inherit that from iterable of G. So what should this G be instantiated over here? This G, generic parameter. So I'll give you a general tip over here. So whenever you use the across over the iterable collection object you're talking about over here, you're going to get one item at a time. So one item at a time. And think about what that particular item's type should be. And that should be your answer for instantiating the G. So now in our case, if you're going across the cart one by one, as we talked about before, what you really want to retrieve is one order at a time. So now the G should be instantiated by order. Okay, we'll see that when we see the class declaration. So now let's go a little bit further. If the cart class actually inherits from iterable, we know that we must implement the new cursor query over here, right? What you can do is you can try to implement the new cursor just by yourself over here. You can say new cursor over here and then it will be effective, and then you want to point that to maybe some other class that you create on your own. That's the general solution. However, in this case, it can be much more straightforward because of the follows. Okay, I'll just show you diagrammatically why it would be much easier in this case. It is because, remember, for the car class, it has an underlying implementation as array. So now you can see array is over here. So there is a client-supplier relation over here, right? And then I believe it's simply just imp or implementation, right? So that implementation is, let's say, an attribute over there. So implementation is of type array. And now, is it possible to now implement something that's of type iteration cursor for the new cursor without creating a new class according to the diagram? Okay, just follow the arrow. The answer is yes. What you can do is you can see array class got the new cursor already redefined, implemented. So that's why new cursor over here is going to give you array iteration cursor, which is itself a descendant class of iteration cursor. So you got it. Right? So think about the diagram over here. This is the supplier of the iterator design pattern. So now if somehow we can find a linkage to some class that's a subclass of iteration cursor, then we are done. If you don't find some such connection, in that case, you have to define your own iteration cursor class, which will be the harder case. But we'll see that later. Okay. So let me simply just go to this coding page over here. Let me show you the detail quickly, and then we'll code it up quickly. So you would say cart will be inherited from, will inherit over here, inherits, let's say, iterable of, so now we need to instantiate the G over here, right? So now one item at a time. So each item should be an order. So that's why we put in order over here. Okay, and then we also need to create another feature section over here, which is public. So this will be iteration cursor. Okay, so now I need to say new cursor. That's going to be iteration cursor. I'm just writing that for short. And now iteration cursor, every iteration cursor is going to be the cursor pointing to one item at a time. So now the G here should be consistent with the G over here, which is order. Okay, let me just go back here, and that would just be order. Okay, and then let's say have do and also end. So now how can we create a result? You can simply say creates. Actually, it's even easier because now we know that the orders is of array of order, so we can simply say result is assigned to orders dot new cursor, and then we're done. So we're doing exactly like this. So we simply got orders, which is array, and then it's going to point to this particular class, a subclass of iteration cursor. And I should notice that maybe this one here, I shouldn't really say this. Orders over here, just to be consistent with the codes you just saw. Okay, let me just complete this easy case just by going back to the Eiffel Studio and show you very quickly. Okay, so now our goal is really to make this particular car class iterable, so we can use the across notation. So now what I would say is I would say inherits, and then I would say iterable. And then, so now every item I retrieve each time in the across loop should be an order. So that's why I would say order over here. And then as soon as I do that, if I say compile, it's going to complain that class has deferred feature. More specifically, it's the new cursor feature from the iterable I need to implement, right? So now let me just go back to the car class. And then what I will do is I'll simply just do feature over here. I can say iteration cursor. Okay, so that will be new cursor over here, and then it's going to be of type iteration cursor. And now the G here typically should be consistent with whatever G you instantiate from the iterable. So this would just be order. And since we are dealing with the easy type, the easy case, so we'll simply say result is assigned to orders over here is something we can use directly. So it's an array, which is guaranteed to have already implemented the new cursor feature. Order dot new cursor, and of course it should be plural. Okay, let me just make sure everything compiles. Okay, so now what we need to make sure is, So now if I go back to this one here, so now you can see for the shop, if you go back to the source code, you will see that this particular order is not exported anymore, so we cannot really use it. Rather than calling call.orders.force, what you should do instead is define some command over here to really provide some mechanism for you to add into the order. For example, you can define the add order in this class instead. I'll let you do as an exercise over here. For now, I'll simply just comment this out in order to just compile, okay, just for now. And similarly, I also got car.orders is empty. You can do something also very similar. You can just define a public query called is empty in the car class, so you can call that rather than relying on car.orders. Okay. Let's say compile. So everything compiles now. Now you can see what's really the main thing for you to pay attention to. It's really about this. So now we can say across cart over here. And then every item we retrieve is simply just an order. And then this particular iterator pattern is really implemented by using over here the new cursor from just the orders, which is a linked list in this case, or an array. Okay, doesn't matter. So all the collection class already got their new cursor implemented. So that's an easy case. Okay, I'll let you complete this particular example over here yourself, and then you can see there are some test cases over there to test the iterators for you already. So you can finish that. That's about the easy case of implementing the iterator design pattern. Let's now move on to the harder case, in which case you have to implement the iteration cursor class yourself. Okay, let's now go on to the second bullet points here. Let's say, for example, if I have the implementation is rather than just array, which is already a library class, let's say I got my tree, for example, it's a splay tree that I defined by on my own. In that case, I don't really have the new cursor implemented just yet for this particular my tree because it's not a library class. So what I need to do is to go for the harder path unavoidably. So what I need to do is I need to create a my tree iteration cursor class that inherits from iteration cursor. And then every item I retrieve may still be an order or something else, right? So that will be the harder path. So let me consider a more concrete example over here and illustrate to you for the harder case what you're supposed to do. Okay, let's switch to iPad here. Let's say this is a problem I'm trying to solve over here. It's very similar to the birthday book problem you solve in the lab number 0. Okay, let's say we got a book class over here. It takes only one generic parameter, and the G over here is really for the data type rather than the key. Let's say we got names over here. It's like a search key. It's simply an array of string. And also we got records. Every record is simply of type G. So depending on what G you really instantiate it into from the client side, G here will be instantiated accordingly. Okay, so now we got names and we got records. So now the challenge we have is how can we make this particular book class iterable? So at the runtime, we can actually say across over here, let's say BB of type book, like a birthday book. And then how can we across BB? So now in order to do it, we need to say inherits over here. And then we'll say iterable. But now, what should we put over here? That's the challenge, right? So now let me figure this out together with you first of all. So remember the tip I talked about before. Let's say if this is the names array over here, let's say this is the records array. Let's say this is the names, and this is the records array over here, right? So maybe you got maybe Alan over here, and then other names, and also this can be October 10th, for example, okay, and other dates over here. So now think about in word. So these are simply just hidden from the client. You can think about these are simply private, okay? And now for the client, in order for them to use across BB, so they should really get one item at a time. How can they retrieve Alan and October 10th as a single item? So a typical way of doing it is to really combine them into a single object. One way is by using a tuple. So you can say it's going to be a tuple over here, simply contain Alan over here. So square bracket is how you do tuple in iPhone. So Alan and also October 10th. So this is a single value and of type tuple and then string and also the dates, right? So now what I will do is I'm going to say tuple over here, and then you can see it's going to be the name and also whatever value it is. So it's going to be a string. Okay, let me just put a little bit simpler over here so I can fit in. Okay, let me just say this. It's going to be tuple of string and the value will still be G, depending on how this G is instantiated. Okay, so this is my instantiation over here. Okay, so now it's really important to understand the tuple over here is considered as a single object. So every time you retrieve from the underlying data structure, which is private, it's going to be a single tuple like this. You cannot retrieve multiple values at a time, only one at a time. Okay, so now the challenge is, how do we implement the new cursor feature? That's a challenge, right? So of course, first of all, we have to say feature over here. So that would be for the iteration cursor. So we're going to say new cursor over here, and then of type iteration cursor, and then it will still be the same tuple over here, tuple, and then it's going to be string. I'll just say it for short, string, and also G over here. Okay, that's a signature for the new cursor. But now, what about the result? Apparently, I cannot simply just say result is assigned to names.new cursor. They wouldn't work because it's only the string. I can also not say, only say records.new cursor. That only give you G only. You want to say combine them together. So what I need to do is to say something like creates over here. Okay, iteration cursor is a deferred class. I can create any concrete class. Let's say my iteration cursor. In that case, I'm going to take the string. I'll take the G as well. In that case, .make. Okay, and then whatever argument it is. I'm going to omit the details here because there will be some tutorial video that will tell you in detail how things should be done. Okay. So now let's talk about the solution quickly diagrammatically. So what we are doing here is, again, the critical classes for the iterator pattern is, you got the iterable over here, and also you got the iteration cursor over here. That's what you have. Okay, so these are the two critical classes. And now what we got is, we got a class called book. And the book actually got two client-supply relation, right? So now one is to the array. Actually, they're both to the array. So they actually got client-supplier relation over here. Okay, so they are the names and also the records. Okay. And of course, for the name, it will be an array of string, and also the records will be an array of G. So I'm just omitting the details over here just to sketch to you quickly. And then we got names and we got records. So the problem is, each one of them is going to give you a separate new cursor. You cannot just combine the two cursors right away, right? So that's why instead what we will do is, we're going to create a new subclass over here that's called my iteration cursor. And that one is going to inherit from the iteration cursor class over here. And then once I inherit from there, I need to implement the item after and also fourth. So item after and also fourth in this particular my iteration cursor class. And then what I will do is, so now the book, you can now return the new cursor over here. So this will be the new cursor. And also don't forget, you have also in the beginning, you have to inherit from the iterable. So now if you look at the whole pattern over here, the harder case, we'll start with the book inherits from the iterable class, in which case we must implement the new cursor feature. In this case, we cannot simply just use the names and records.new cursor. We cannot use them to combine them directly. So what we do is, we're going to create a new subclass over here called my iteration cursor. That's going to inherit from new iteration cursor, and then we're going to implement new item after and fourth. That's what we got to do. Okay, so now you can see the diagram is still going to connect from the book into some class that's a subclass of iteration cursor, so it will still work. It's just harder path that we have to take. Okay, so that's about the this particular harder case. And then if I go back to the let me just go back to here. Okay, you will see this one, this slide here. Let me go by the iPad. So this one gives you a little bit more detail. So this is iterable, and that's my book class, right? And that's a new cursor. And now my iteration cursor over here is actually going to inherit from iteration cursor. And then each item is going to be tuple of string and also G, as we talk about. So now you have to somehow, typically you will simply take the all the private data structure from the supplier class over here. So now in this case, I'm taking array of string and also array of G over here, so that I can use them over here. And a very typical way of implementing the iteration cursor would be, you just use some attribute over here for the cursor position. You're going to move the cursor position one at a time. I'll give you some visual hints in just a moment. And also you got the names and records. They are simply initialized from the names and records over here. Okay, and then you have to implement the item, the after, and the fourth over here. Item is simply means depending on where the current cursor position is, you gotta return that particular item. After simply means is the cursor now the end of the iterable objects. If it is, there should be no more item that can be called. And also fourth, you just move the cursor from the current position to the next one. That's what it will do. Okay. So that will be enough hints for you, and you can think about this particular standard implementation. You can easily finish that on your own. Okay, and before I conclude for the supplier side, I want to give you one more visual summary about what we're doing over here. Okay, especially you can think about this is more like a harder case over here. Okay, so now let's think about another class here. Let's say we got a class called array map. That's our customized class, and then it simply inherits from iterable and a tuple of string and g, very similar to the book, right? So we are saying that we're going to implement the iterator design pattern, and then when we say across, and then maybe array map, I'll say a map, and then every time let's say is some cursor, okay, maybe some entry, and then what's going to be the type of e? So we're going to get e one item at a time. So now you can somehow use, for example, in the loop over here, you can say e dot something. So what should be the type of e? So each e will now be just a tuple. Okay. So how can you visualize this really? If you think about it, let's see this. So when you create your iteration cursor class over here, okay. So whatever that's in the dark color, so these are private. In this case, we got values 1, values 2, maybe the names and also the records, and also the cursor position. Remember the cursor position we saw here? The cursor position, and also the names and record, they are all private, exported to none over here. So these are the fields that will not be accessible by any potential clients. All the client can get access to are the item, after, and fourth. So these are the public features from the iteration cursor over here. Okay, so now, so these are what the client can do. So think about what they are really doing here. Okay, so the at the runtime, what's going to happen is the clients can get hold of this particular iteration cursor objects, but they cannot get access to the underlying private attributes over here. So what they would do is they would simply say, this is a typical way of running a loop over the iteration cursor. So they would say from, so let's say array map, right? Let me just say m, assuming that m is of type array map. From and new cursor over here. So as soon as you say new cursor over here, it's going to return back to you an iteration cursor objects, right? So now, of course, you can, assuming that we got IC of iteration cursor over here of type tuple of the string and also g over here. Okay, let's say IC. So initially, IC will be initialized to be the new cursor until, let me just write down the typical loop. IC dot after. That means the cursor is now beyond the end of the iterable objects. And then we can say loop over here. You can definitely get access to IC the item. You can do something about it. Okay, I'll omit the details for that. And then every time you're going to say IC the fourth over here. Okay, so these are the critical features you have to notice. New cursor first of all, and also the iteration cursor operation. You got item, you got after, also you got fourth. So these are something that's accessible to any clients in the public. So let's think about what's going to happen here. So now when you do the initialization over here, when you say IC is assigned to, right? It's assigned to, okay, it's an assignment over here. It's assigned to m new cursor. So that means the clients actually got IC that is pointing to this particular cursor object over here, right? And then when they say IC the after, initially the cursor is only just going to point to the very first objects of the underlying data structure. So now after will just be false, which means I can still go on to the loop over here. And when I say IC the item over here, it's just going to say, because currently the cursor is now pointing to the first item for both linear structure over here, so it's going to return both of these as a tuple over here. So now for the first iteration, this is what's going to be returned for the item, the very first iteration over here. And then when you say fourth over here, it's going to move the cursor. Let me just use different color just for the second iteration. When you say fourth over here, it's now going to say, rather than pointing to these two positions, so now values 1 is now going to point to the second index over here, and values 2 is going to point to this particular position over here, right? So now when we go back to the exit condition over here, so IC currently is pointing to the second element of the underlying data structure. So after will still be just false. So we're going to continue. In that case, when we say IC.item over here, which is public, is now going to return these index 2 items as a tuple over here, and then that one is going to be the return value for IC.item, and then etc. Finally, if I say fourth again, it's simply going to say it's not going to point to the second elements anymore. Instead, they are going to point to the third elements accordingly, right? You can see the cursor simply just move from left to right, one position at a time. So from the client's point of view, let me recap. From the client's point of view, they can only say, I want to assign some iteration cursor to this iteration cursor object by calling new cursor. And then I can now use after item and fourth to actually go over the underlying implementation one element at a time. Okay, so that's really what's happening here at the runtime. So you really want to get some visual intuition about how things work before you can really implement the harder case, which I already gave you about 95% of the code already. So now let's go back to the slides. Okay, so that's about the harder case, and then for the rest of the slide, you can simply follow through. Everything has been gone through already. Okay, so that's about a simple case over here, and this is about the harder case. Okay, my iteration cursor, and that's a skeleton I gave to you. Okay, you can figure out the details, and that's a visualization I just did. So now, what about the exercises over here? I would say, number one, you may actually want to consider drawing the bound design diagram for both the simple case and the harder case. I have already gave you some hints over here. So this is the harder case for the bound diagram, and this is a simple case for the bound diagram, right? Although it's an informal sketch, so you may want to make it more formal by conforming to the syntax for the bound diagram. Okay, that's something I'll leave to you. Okay, so now let me go back to there's one more thing over here. So for the harder case, I didn't give you the complete code because the rest of the details should be quite easy to follow if you really get an intuition from the visual illustration I did. If you really want to follow through some more detail, like a hands-on programming tutorial, you can refer to these three. So these two are really about how you can do the iterator pattern. And this one is from the previous lab test about how you can make your birthday book, in your case, like a lab number 0, how you can make the birthday book implementing using hash table iterable. So these are optional if you want to find out more about the iterator pattern. But with the concept that we talk about in the lecture, it should be enough for you to actually figure out the programming details.